Hello, math students. Today we're going to start our new unit on polynomials. You've used polynomials in the past, you just didn't know what they were called before, but today we're going to be adding and subtracting with polynomials, which basically is going to be combining like terms. We do have some vocabulary to talk about before we start actually doing the adding and subtracting. We're going to be talking about monomials and the degree of a monomial. A monomial is just one term. The prefix mono means one. So we're talking about one part of an algebraic expression. It can have multiplying. We can have a coefficient, a number, we can have variables. We can have as many variables as we want with exponents, but there can't be any adding, there can't be subtracting or any dividing. The degree of a monomial is I'll take all of the exponents and all the variables in that monomial and add them all together. It's going to be the sum of all of those exponents. So in these examples, each of these is a monomial. I've got variables, I've got numbers. I realize that the 1/2, -1/2 looks like it could be a division if we're not careful. It's just a number though. -1/2 is just a number. So the degree of each of these monomials will just be about the exponent. So the degree on the first one is just 2 because that's the only exponent that's there. The degree on letter B is actually 4 because you can see this 3 that's on the y, but there's also a 1 on that x. So we would add those two together. The degree of letter C is going to be 6 because we're going to add the 3's together. And letter D is kind of a trick question. There isn't a variable. I said the degree would be the exponent on the variable. No variable. The degree is going to be 0. So in these problems, similar kind of setup. Number 1, the exponent is going to be a 4. The degree is 4. I don't care what the coefficient is, what the number is out in front. That doesn't matter at all. For number 2, when I add those exponents together, I get 5. For number 3, there's really a 1 there if I don't see anything else. And for number 4, that's going to be a degree of 0 because no variable, no exponent. Now, when we have more than one monomial, we put them together. Polynomials are monomials or additions of monomials. So I can have more than one term that's all being added. You know that if you see something that's a subtraction, it's really, you could change it to adding the opposite. So when I have 2 terms, that's going to be called a binomial because the prefix bi means 2. So this binomial, the 5x is one of the terms, one of the monomials, and the 2 is the other one. A trinomial, use a different color so it doesn't run together there. Trinomial starts with tri, that's 3. So I've got 1, 2, 3 terms in this trinomial. Some of the problems that we're going to go through in the examples are going to ask is, what kind of a polynomial is it? Monomial, binomial, trinomial. Count how many things are getting added together. When we talk about the degree of a polynomial, that's a little different than the degree of a monomial. When we take a polynomial, we're going to put them in what's called standard form. I've mentioned standard form a whole bunch of times. In terms of polynomials, that just means biggest exponent down to the smallest exponent. So when I'm doing this, the degree of the polynomial is just the degree of that first term, the biggest exponent part. So this one will have a degree of 3. We'll also ask about the leading coefficient. Coefficients are just numbers in front of the variables. The leading coefficient, when I put this all in order, is just going to be the first number. That's what leading means. The other thing that we've got defined here is a constant term, and I've mentioned constants before, but not everybody remembers that term, I'm sure. A constant is just a number, no variable. Variable means it can vary. X could be one thing in one problem, and in the next problem it could be something else. It varies. A constant is constant. In this case, this is 12. 12 is just going to be 12. It's not going to change into a 24 or a 37. It's just going to be 12. In this problem, I want to put this polynomial into standard form. And then I want to talk about what the degree is and what the leading coefficient is. So when I see 15x minus x cubed plus 3, I would maybe do a keep, change, get a 1 in there. Then I want to put these in order. I want the biggest exponent first, which is really that negative 1x cubed. And then I would have plus a 15x and then plus 3. The degree, remember that's just the biggest exponent. The degree is going to be 3. The leading coefficient is just the number that's in front of the whole thing, negative 1. So in these, I want to do that same thing. I want to put it in standard form, find the degree, find the leading coefficient, and I want to talk about a name based on how many terms there are. So for number 5, this is really going to be negative 9z plus 4, right? I said this is going to be biggest exponent. The exponent on the z is just a 1. The 4 is an exponent of 0 on the variable. The degree is 1 because really, there's 1 right there. The leading coefficient is negative 9. And this has 2 things that are getting added, so that's going to be a binomial. In number 6, putting these in order, I would have negative 1t to the third. You guys know you don't really need the 1 there, but you do need the negative. Plus t squared, and then plus a negative, or I guess I could have just left that as minus 10t. The degree is going to be 3 because of that biggest exponent. The leading coefficient is negative 1. And this has 3 things that are getting added together, so it's going to be a trinomial. And in my last problem on this slide, I would want that x cubed first. And the degree is going to be 3. The leading coefficient that I don't see is actually a 1. And this has 2 terms. So again, it's going to be a binomial. This is really the majority of the work for today. Adding, and then the next slide is going to be some subtracting problems. When I'm adding, I need to put the answer into standard form, and I'm just combining like terms. Again, you've done that quite a bit. So the biggest exponent would be these cubes. So I've got 2x cubed, and then another 1x cubed would give me 3x cubed. Then I would go to my x squared. So I've got a negative 5x squared, and a positive 2x squared is going to give me a negative 3x squared. The things that I've left, I have an x and I have a subtracting 1 or a negative 1. So I would just go plus x and then minus 1. They don't match. They don't go together. So this doesn't have a nice name like a monomial, binomial, trinomial. We would just call this a polynomial because once we go more than 3 terms, we just call it a polynomial. For letter B, these 2 happen to be in standard form and everything all matches up. So I'll have 3x squared and then another 1x squared would be 4x squared. Then I've got a 1x and a 4x would combine to give me 5x. And negative 6 or subtracting 6 and adding 10 would be plus 4. When we find the difference, which really just means subtract, I don't like students to try to do the subtraction the way that it looks. We have 2 options. I've got kind of a longer way, and then I'm going to show you my shortcut way of doing this. I would consider doing a keep, change, put a negative 1 there, and then we would have to distribute that negative 1 to everything, which is fine. But distributing a negative 1 doesn't do anything except change the signs. Instead of doing that distribution and having to rewrite the problem, I talk about it like adding the opposite. So I'm going to change this to adding. And then everything in the parentheses after it has to change to the opposite. So if it's a negative, it changes to a positive. If it's a positive, it changes to a negative. And that'll change to a positive. It's exactly the same as just distributing a negative 1. So I have 4n squared. Now it's plus 2n squared is going to be 6n squared. That was that and that. Then I just have a regular 2n, so minus 2n or plus a negative 2n. And then my numbers, I've got a 5 and I've got a 4, that'll be plus 9. Same thing in letter B. I would do a keep, or adding the opposite, opposite, opposite. Just change each thing one time. So I've got a 4x squared and a negative 3x squared would be 1x squared, or just x squared. Negative 3x and positive 1x would be negative 2x. And then 5 plus 8 will be 13. These last 4 problems, I'm just going to kind of speed through just so that you can see them, but I'm going to try to go as quickly as I can so that I can kind of keep this shorter. 1b plus 4b would be 5b, and then negative 10 and negative 3 is going to be negative 13. My x squareds would give me 8x squared. Negative 1x and another negative 1x would be minus 2x, and then I also have a minus 2 at the end. When I do my changing here, I'm going to add and then opposite, opposite, opposite. So I have 1p squared plus 4p squared is 5p squared. A 1p plus another 1p is going to be 2p. And 3 and negative 3 would just cancel. I would not put a plus 0 at the end on that. And again, we're going to add and then opposite, opposite. So I have negative 3k squared, my biggest exponent. Then I have just this regular subtracting k. And then the only things that match are this 5 plus 6. Today's worksheet is the camping on the Sahara Desert. It's a riddle kind of a worksheet. You are adding and subtracting, combining like terms. The answer key is in Schoology. When you're all done with that and you checked it, make sure that you take the formative. If you need any help with this, let me know.